recent papers, more than 50%, that means half of the chilies are produced in China. And for pumpkins, around 30%. For watermelons, nearly 70%. So you can see that it is really the biggest vegetable producers in the world. And to the right side, you can say in 2016, the production of Chinese vegetables takes about over half of the world total. Okay, so that means if you are an international person, every day each kilo of vegetables you eat, half of it come from China, and which gives opportunity for Chinese people to eat more vegetables than any other countries. From here you can say, for each people in China, every year we have the vegetable consumption over 500 kg. So that's a huge number. So yesterday, Miguel, or how to pronounce that? The gentleman, Miguel, okay. The gentleman in the back, supporting you all the time, asked me, how can I keep to be looking so young? I'm not quite sure whether you can just imagine how old I am. What? Means I'm 46, and so the gentleman said, is that due to vegetables? My answer is no, I don't know, because I don't think I'm a grass-eating animal like grasshopper. But we do in China, we have the opportunity to eat quite a lot of vegetables every day. And China is also the biggest vegetable exporter in the world. This is the data just to show you, covering the 12 months during the 2015. On average, the exported vegetables from China each month is around 0.7 million tons. So that's a huge number of vegetables exported to many different countries in the world. I'm not quite sure about Costa Rica. Possibly you already have something imported from China. And also some of the information just to show you, in this country you must have more attention to fruits. And this is a chart to show you how much fruits we imported from the other countries and also exported to the world. It's quite to be balanced with a huge amount of money. So if you are working on fruits or the other vegetables, possibly you need to think about it. China is the biggest market in the world for agriculture. Okay? So you may ask, why in China farmers tend to grow too much vegetables? The answer is, all our farmers, not even in China, but the farmers everywhere in the world, they are looking for economic returns. They care about the money they can get from the field. I'm not sure they care anything about the actual demand. So I think that's quite a typical symptom in China. Because in China, vegetables can benefit the farmers far more than the other crops. This is the thing I can show you. On average, to grow a certain unit area of vegetables will bring back 10 times the benefit to farmers. So in this way, vegetables are always considered cash crops in China. And since the farmers can get more money back from vegetable production, and That attracts farmers in China across the whole country to grow more and more vegetables nowadays. You can see here for cabbage, and sometimes the farmers produce too much, and they cannot sell their products to the market. So that's quite common, or that's quite easy to understand. And sometimes a lot of vegetables are thrown away, dumping into the rivers or piled up along the roads. And in that case, the farmer is in the city, in the field, not smiling but crying. So that's the thing that happens nearly every year in China. And if you know something, the more thing about China, and I can tell you, most of the vegetables are produced from the east part of the country. You might notice the circle there. In those provinces, farmers produced more than 50% of the vegetables in that country. Actually, the bottom circle, you can say over 50% of the national vegetable production is produced there. The reason is, I can tell you, most of the eastern part of China is densely populated, and most of the people in China are living there. And also, from the top, that's Beijing, the capital city of China, and also that's maybe I can show. Okay, Shanghai is over there, Beijing's there, and all the people, quite a lot of people are living here. So that makes the market needs is very, very high in that region. So over the, well, to cover the most of the eastern part of China, around 70% of the vegetables are produced there. That's the place I come from, this one. If you got a chance to visit China, welcome to that province. Just as I said, China is too big. It is the third biggest country in the world, following just Russia and Canada. So that's the problem. And then in the middle, you can say China is also the biggest country in population. So we have around 1.4 billion people living in that country. So divided by the population, we would like to say each people in China has a very, very, very limited piece of land. On average, each people has less than zero point 0.1 hectare of land. So you can say that's nearly about the size of your backyard garden. So that's a very small piece of land. So in this case, if the farmers with very limited land, if they just want to produce more vegetables, they must try to find something to do. So the protective cultivation in China is now very, very common, just like this. And the farmers have to increase the multi-cropping index, which means in each year, the farmers can have more than 2 or even more than 3 or even more than 4 crops in their land. And also to produce the off-season vegetables, which means during the winter time they can produce something used to be produced during the summer. So that's the way we are doing in China. And to do that, now we have around 4 million hectares of various protected cultivation. 4 million hectares, so about the size of this country. So which means the whole country is covered by glass. And also, in some factories, we are doing the containerized vegetable production. I'm not sure whether you know the definition of the term, but which means we can use the hydroponic vegetables. That's over there. Yeah, because in that way we can just grow vegetables on top of the liquid media rather than the soil. And also we can do the multi-storage cultivation, which means to pile the crops up into layers, just like the buildings we are living in now, to save the space. So that's the way we can think to increase our yield of vegetables on top of the very limited land there. Okay, and due to the enormous market needs, and the vegetable breeding in China is now highly promoted and with very significant progress. And the overall competitiveness of Chinese vegetable breeding is now above the world average. In some specific fields, and China now is in the leading position. So that's the thing. Your scientists might look into and try to find something with a mutual interest and try to establish some sort of collaboration work between you and my country. And first, to give you some idea about how many people now in China are doing the breeding work on vegetables. And currently, there are 179 breeding institutes or sectors about the municipal level. Among them are 143 research institutes with one state level, that means the country level, and 33 provincial level, and 109 city level. And also we have 36 agricultural universities in China throughout the country. And all these institutes or members, operators there are financially supported by our government. So they do not need to worry about the salaries, and the country just gives them the money, their salary. So you can say there's a big difference between China and here or the other countries. And in total, at least more than 2,000 scientists and breeders are now involved nationwide working on vegetable breeding. And each year, we have hundreds of PhD students graduated with their PhD degree from universities. So you can say the capacity of Chinese breeding is now increasing year after year. I'll just give you a quick example of chili peppers. There are 28 governments financed or supported institutions or universities or sectors now involved in pepper breeding. So you can see we are because China is the most populous country, and for everything, if we want to do, we have a lot of people to do that. So if you think your country failed compared with China in vegetable breeding, you do not need to worry about your capability or that sort of thing. You just need to know you don't have enough people and enough money to work on it. It's just like a fight. They have 10 people, just fight you, only one, we will win. And also China now has around 8,000 companies, either public or private, marketing with vegetable seeds. Quite a lot of them are doing their own breeding as well. So in this case, you can just open up your idea about how many people now in China are working on breeding. And so, in China, with the production, still we need the seeds. And China now needs 40 to 50,000 tons of vegetable seeds, with the total seed market value around 2.7 billion US dollars every year. So you can see how big the market is. And if you come from a seed company, you might need to think about it. And unluckily, we Chinese cannot produce enough seeds for ourselves. Each year we import over 1,000 tons of vegetable seeds and with higher yield, of higher value. So which took over 25% of the Chinese vegetable profit. Most of the biggest countries we import the vegetable seeds are like Monsanto, everybody should know that, Syngenta, etc. All the famous international seed companies. And now we also export some seeds to some southern parts of the Asian. That's because different countries we have different needs, and our companies we provide some sort of seeds which will match the needs from some of the other countries, such as a low price, and 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 also at the same time we import a lot of seeds from American countries. So that's the situation now of the import and export of the Chinese seeds, of the vegetable seeds in China now. And so let's move on to plant breeding. Basically, plant breeding is the art and the science, both the art and the science of changing the genetics of plants for the benefit of humankind. And plant breeding can be accomplished through many different techniques, ranging from the simply selecting plants with desirable characters and to the more complex molecular techniques. So that is the concept of plant breeding. And things my PPT will be here in this computer from the University of Costa Rica. I'm not suggesting you to copy or to write down the words showing on the screen. I'm quite happy for you to download whatever you want from my PPTs, and you can use it any place you want. You do not have to worry about the property right, and I'm not going to ask for any royalty payment, so you do not need to worry about that, and you just feel free to copy it after the workshop, okay? So we can go even quicker. And plant breeding has been practiced for thousands of years, as I just mentioned earlier, and since nearly the beginning of human civilization, so that's no problem. And now, blah blah blah, the words, that's no problem. You do not need to waiting for me to read it. It just goes through. And so, from the concept and definition, it is quite clear that breeding is the process of making or creating or selecting the differences. If you have two things identical to each other, just like making a photocopy in the laboratory, we will say you are not doing the breeding work, because you are just copying the other people's work and you are just selecting something or to steal the variety from somebody else. So most of the scientists or breeders are now looking basically from the phenotype differences of a variety or of a new plant. But basically, any phenotype differences must have their genotypic differences background in them. So we can just try all our best to produce the difference from there, and then to give you the phenotypic differences. And naturally, that difference will be used into a new variety. So, if you are a breeder or vegetable breeder, you must you must start your breeding work from collecting different different germplasms or different materials. If you don't have the differences in your head, it is very difficult for you to start your breeding work. And luckily, the nature has already provided enough differences for us during the long time of life evolution. So from here you can say, with the term of biodiversity, you can say in the nature we've already had a lot of different a phenotype of every species. For example, for potato, with different shape, different color, different even nutrition level or whatever. And also to that side for beans, different colors, different size, and different blah blah. And also for apple, for the other vegetables. So that's the thing we need to care about. That's called the germplasm. And now the China, the country, started to collect all the germplasms of various vegetables from the early 80s, and now there are more than 36,000 vegetables germplasms are now stored in the National Germplasm Storage in China, which located in Beijing. So if you got a chance to visit Beijing, and if you do have interest of some of the original germplasm of vegetables, you better come to that institute and ask for some of the seeds. If you are lucky enough, you will have your seeds free of charge. And which makes the China the third biggest country in the world with their germplasm capacity, following just after the USA and Russia. So with the germplasm, we can move on to breed our new varieties, which we can just choose or start it from the conventional breeding method. That's the thing we are saying today about traditional ones, or also the classical. Fundamentally say is the process we are doing the hybrid or to do the cross-pollination. So on the basis of the theory of heterosis, so which means the hybrid vigor, and that's the thing was first observed during the end of 18th century and confirmed during the early 19th century. So that's a very old theory, but now it's widely used in vegetable breedings. And just some of the early facts with the artificial hybridization, and you do not need to copy it, and just to say the first artificial hybrid was produced during 1770, and for carnation, that's a flower name. And since then, scientists have already produced more hybrids in different crops, and such as the tobacco, or the other crops. So if you do want some of the ideas and some of the words in your publication or in your proposals, you can just literally to just copy this sort of information. Okay. And about the advantage of hybrids, we always know hybrids will have some sort of increased performance, such as higher yield. This is a very typical example of hybrid maize. And both the male and the female parental lines in the middle, that's a hybrid. You can see the size of the ear quite big, and the yield is much higher than the parental lines. And also, we're looking for the enhanced resistance to different stresses from the hybrids, and also the improved suitability, and also for better quality. And all these things can be realized by hybrids. And actually, the natural cross-pollination works all the time. Maybe we are not very keen on this, but it appears or it happens all the time. Mediated mainly by insects or even by wind, because the insect can just bring pollen from one flower and fly and drop the pollens down on top of the other flower. So that's a process happens, and which is also the promotive factor for life evolution. And the artificial cross-pollination, which means used in our breeding work, started from Darwin and Mandel's work. And those two guys are very famous, and you can find their stories from all our textbooks. And firstly, they did something like called the intraspecific hybridization, which means hybrid between two varieties, but within a certain plant species. And with their work, even with Mandel's work in the early 20th century, scientists realized his theory on non-random nature of inheritance was very, very important. And that comes to be a milestone for our modern genetics. And that's the way Mandel's work started. That's the artificial pollination. So with one flower to your right side, there's a white colored flower, and to take the pollens out of the flower and then pollinated the pollens to the left side flower on top of the pistil, and to produce the F1 hybrid, and which is called the hybrid. And both plants or the flowers with different colors or with different functions are called now called the female and male plants or lines. And for the right side, we just need to collect the pollens. We do not need to worry anything about the others. But for the right side, left side of the flower, things we need to make sure all the pollens the flower get come from a different flower. So in that case, we must do something like the emasculation, which means we take off all the male organs out of the flower, which are the stem. So that's the word we used in cross-pollination, emasculation. This is a very fundamental role of segregation. If a certain trait is determined by one pair of dominant gene in F2 generation, then we give you the 1:3 ratio of the segregation. So that's the very basic genetic theory. So I don't think we need to go quite deep inside this. So if you have any background of biology, we must be very clear about these facts. And so, in doing the breeding or cross-pollination breeding, we need to worry about the flower because we are working with the flowers. And in the nature, we have two kind of flowers. The first one is called the monoecious species, which means in a certain flower, there are both the female and the male organs inside. So in that case, if we are doing the cross-pollination, the female flower needs to be pre-treated earlier to take off the male organs away, just to guarantee all the pollens it gets come from the flowers you choose. And also there's another kind of flowers or species which is called dioecious species, which means in the flower it will have either only the female or the male organs. So in that case, it's quite easy for us to handle the cross-pollination. So most of the melon species are in this kind. So you can say the top picture is the female flowers. Once it's pollinated, it will be the fruit. And for the downside flower, it's called the male flower. Its function is just to provide the pollens. it can never bear any fruits. Is that right? Okay. For scientists now in China, we are doing the cross-pollination. There's a few pictures, and on top, we need quite a lot of people, or students, or laborers, to do in the field. Doing what? To pick out of the stems, out of the flower, to make them ready for the pollination. And also for the bottom picture, that's canola, or oilseed rape. And we need to cover the flower and take off the stems from the female flowers. So you can imagine how hard and labor's work we need to do every year, because we are doing a lot of cross-pollination every year. So we need a lot of people working in the field. Nowadays, it's not easy for us to find enough people, so we need to think something more to deal with that. And also, if we are going to work on maize, it's a little bit simpler, because for maize, the flowers that on top, which we call the flower is the tassels, and that's the female, and that's the male organs, and in the bottom there will be the female flowers. And if we just need to pick out of the old tassels from the behind, from the inner side, inner lines of the plants, and all the seeds collected from them are called the hybrids, because they cannot do anything as we call the self-pollination. So the pollens must come from the male lines. This is a picture for the seed production of watermelons. So, is it quite familiar to you? With farmers to pollinate flowers one by one and to produce hybrid seeds. And that theory, Victoria's theory, was introduced into China in the 1980s and possibly late 1980s. And the hybrid breeding in China is now the leading breeding method in vegetable improvement. Until now, that theory has been successfully developed in around 27 vegetable species. And within the past 30 years, several thousands of vegetable varieties have been released. For example, during the 1980s to 2004, more than 2,680 new vegetable varieties were registered and released. And some of the important vegetables, such as the Chinese cabbage, broccoli, cucumber, and sweet pepper, and tomato, watermelon, and muskmelon, for these varieties, and over 50% to even to 90% of the new varieties are hybrids. Just give you a quick example of how we breed watermelon variety, which is called Xinyu number 10, by breeders from Tianjin city. And they started from the germplasm collection, and sugarly some sort of on the top, those names are were coming from the USA, or even from Taiwan province, and then they crossed the different germplasm and produced different lines. They choose from the lines, both the female and male lines, and cross-pollinate the two lines and produce the new variety with a very high yield and very wide suitability to different situations. And after around 10 years of the procedure, the variety was registered in 1999, and still now it is one of the biggest vegetable watermelon varieties in China. So that's a basic idea. And also an example of the muskmelon variety, which is called the storage crown, coming from the host company, Jianghui Horticulture Company. And that was also following the same way to select the correct female and male lines, and then after crossing, they produce the hybrid with high yield and very well improved the storage time. And so far, most of the varieties in its company were bred following this method, the cross-pollination. Uh, if you're tired, I'm sweating anyway. Okay, so, well, just write up. You don't need to show me like this to be very serious. Just take it easy, okay? And since to do the cross-pollination or producing the hybrids, the first step, as I mentioned, is the treatment of the flowers. If we want to do a lot of breeding works with so many different varieties, it is a big problem with a lot of people helping us in the field to treat every flower. So that's very difficult to deal. And so scientists tried, and luckily they found something which is called the male sterility, MS, which helped the breeders very much, because for this system, for the male sterility, which means there will be some sort of mutant variety of flowers. In the flowers, the male organ are aborted, which means they cannot produce any pollens. And all the seeds beared from that flower must have pollens from the other flowers or even other species. So that's the very good news for the scientists or breeders to do. Because with this sort of system, we do not need to treat the female flowers before the cross-pollination. And on the basis of the genetic background, the MS can be divided into different types. If the male sterility gene is located in the nucleus, which is the system we call the nuclear male sterility, in short NMS. But if the genes linked to the MS are located outside the nucleus, which means the genes are in the cytoplasmic organs. So that sort of system, which is called the CMS. And if the genes involved are located both inside and outside the nucleus, which is the system of interactions between both, and which we call the cytoplasmic nuclear male sterility. So that's the three different male sterility systems we are now using. And the easiest or the most classic example of the male sterility is called the three-line hybrid. We must prepare for three lines. The first A line, which means the stereo line, MS line, as the female, because the male organ is aborted. And also with the B line, which means the maintainer line, because with the line it cannot bear its seeds for itself. It must have some sort of maintainer to keep the MS trait for propagation. Otherwise, you will lose the mutant easily. And between the cross between them, between A and B lines, and then we produce the F1, is also the male stereo line, and also we need crossed with the third line, which is called the R line, with the restore gene. We need to recover the sterility or fertility of the line to produce the seeds. Otherwise, no seeds will be produced. And cross between A line and R line will give you the hybrid seeds. So that's the three-line hybrid. And China is now in the leading position in the following fundamental and the applied studies. And the cytoplasmic and nuclear mastery mechanisms have already been cleared in radish, and the NMS mechanisms in cabbage, and also the studies on three lines combination in sweet peppers and breeding for pure male sterility line in onions. All these things are realized in China by Chinese scientists. And some of the reports or publications were first published by the Chinese scientists. And with that sort of technique, use the mostly traditional hybrid way or even the three-line hybrid, and we can say the yield, the average yield of Chinese vegetables are now in the increasing. So this is the example of pumpkins. So you can say the average yield is in increase year after year. So that's the long tendency. And the pumpkin, you can say the average yield, that's the middle line, and we are quite high compared with most of the other countries. We are not in the lead, but the average yield of Chinese pumpkins are now quite high compared with most of the other pumpkin producing countries. And watermelons, which is also quite clear about the yield increase, I mean the average yield increase year after year. And watermelon production, as I just said, takes about around half of the world total, and the average yield is now 14,000 tons. So you can say, compared with the other countries, some of the selected big watermelon producing countries, you can say 40,000. That's the average yield of China is nearly on the top. And Chile, again, you can see the tendency of the average yield increase. So that's the fact from the hybrid vigour. So our scientists or breeders are now trying to choose the hybrid with very high yield. So that makes our vegetables now produced at a production, the yield increase year after year. And with doing that, sometimes scientists or breeders are not very happy with the cross only between certain species. Sometimes they try to use different species and try to map the cross. Problem is, if the selected species are far away in relationship with each other, most likely they cannot have a hybrid with seeds, which is called the incompatibility, which means they fail to produce a hybrid with the hybrid seeds. But what will happen? What will be happened if the breeders is keen on the interspecific process? Because from the very far away relatives of a certain species, there are some sort of very good or very interesting traits, such as the stress tolerance, or even the disease tolerance or resistance, or that sort of thing, or salt tolerance. And if we do want to move or transfer that sort of genes or resistance back into our cultivated varieties, what we can do? If they just try to do that, and the cross-pollination failed to be ending seeds. If they do want to do that we can try to do something helped by the technology. So we can just discuss a little bit about biotechnological breeding. And in that case, the easiest way for us to do or start with is called the in vitro culture. which is also called the tissue culture or cell culture. Is that right? And in vitro tissue culture is like this. And I noticed yesterday we have a laboratory here in this department, and the students they are now still doing the in vitro tissue culture here. So this can be quite familiar to you, and that process is following the theory of the plant cell totipotency. Anybody knows that? Then, which means every single plant cell can be used to regenerate a whole plant. And basically, that sort of idea. And that theory was given by a German botanical scientist in 1901-02. So we can start from a single cell or tissue or organ or all these sort of things. And after generations of the culture and induction, a new and identical or exactly the same plant will be generated. So that's the procedure. And looking inside the procedure, you can say the first day there will be the mass of callus formed, and that callus looks quite similar to the cauliflower head. If you have the appearance, you might know that. And then to use some sort of plant hormones, and we can induce the shoot, and also later to induce the roots, and to produce the whole plant leaves. The tissue culture has been mostly used, I mean, about 20 years ago in China, in getting virus-free plant leaves, such as in potato or sweet potato, garlic, ginger, and strawberry, etc. in China. That was once a very big market and industry in China. The factory sold their seedlings to the local farmers because without this sort of technique and quite a lot of plants in the field will easily be contaminated by virus, and then the virus would kill the plants and even the whole field, and the farmers will have no sale. So in that case, if a factory can produce the virus-free plumage, and the farmers were very happy to buy, and which got back very good, market for the companies in China. But now that side of business now is going down. Because the farmers are now knowing they can use different kind of chemicals to treat different problems in their field. So that's okay. So just as I said, if a cross is made between species with a far away distance of relatives, which means different species, and sometimes there will be no seeds, as I said, but sometimes the hybrid can give the scientists or breeders immature embryo. So that embryo will be die shortly, but it can live for some time. Such as in B, there will be the embryo inside, and if during a certain period of time you pick out of the embryo and culture it on some sort of media, and you possibly can germinate the whole plant, which is called, that process is called the embryo rescue, which means to save the embryo. That's the whole procedure of that sort of work, and to get the embryo and to culture it on the medium, and then you get a new plant. And also in China, some people or some laboratory from Nanjing Agricultural University, they did quite similar work. And from the interspecific cross-pollination of cucumbers, they produce the failed or the aborted embryo. And then to use the embryo rescue method, they produce the hybrid. So that's the way. And I noticed the clock there, which means we can have a rest here, just for a cup of tea, if you would like. Okay? Right. And since this is the last day, and I'm quite nervous here, uh, possibly we have a lot of story to tell. Would you please just come back within 15 minutes time? Okay? 1-5 rather than 5-0. All right, okay. So, thanks. I'm not clear enough for you. 啊 well, I think so just as I said, I'm a quick speaker. I want to be everything quick. Yes, some students from in USA, it was 5 to 8 years.
Well, I guess they see students as slaves, cheap labor. So if you have someone working free at the lab,
Yeah, very much. So the professors do not need to hire
yeah.
any technicians or
So they try to
scientists.
keep us working there plus laughing.
La pastilla. Pondría en pausa. Con el comentario que iba a hacer con asunto de migración, dice que los extranjeros que no han regularizado su condición se apersonen a las otras.